Hello everybody and welcome to video 3 in this Python web scraping tutorial series. In this video, I'm going to be showing you how we can actually navigate through the tree, so the tree structure that's generated by reading in an HTML document. Specifically, I'm going to show you how we can do this to actually find the prices of different cryptocurrencies. So I have this window right here, which is coin market cap open. Notice there is kind of like a table here of all of these different coins, and I'll show you how we can kind of iterate through them using some different functionality of Beautiful Soup I've not yet showed you, get the name, and then get the price. With that said, let's go ahead and dive in. All right, so let's go ahead and get started. In front of me here, I have the website coinmarketcap.com, which has all of the popular cryptocurrencies. And then I've opened it up in Inspect Element, or opened the Inspect tab. The way you do this in Chrome is you right click and you press Inspect. You can also do Control Shift, and I believe that's an I. Anyways, you can see this is kind of what the HTML is looking like. And the data that I want here is inside of this table. So if you look here, I'm going to highlight over T-body. T-body is what I'm looking for. I want to see the data in this table. And so what I'm going to start by doing here, and notice I already have the code that actually loads in the CoinMarketCap HTML. Just wrote the URL, got my request or sent my request, grabbed the text, and then read it in with Beautiful Soup. But what I'm going to start by doing is looking for the T-body tag. So I'm just going to say doc.tbody. I think this should work at least, and this should give me the actual table body. So T-body is equal to that, and let's print it, T-body. Okay, when I print this, we do indeed get the table body that we are looking for. So what I want to show you in this video is how we can navigate by looking at things that are on the same level in the tree. So if we have a look here, notice that T-body is the parent of all of these table rows. And all of these table rows are on the same level in the tree. So what I could do is just get all of the contents of the table body and loop through this, right? And I think I showed you how to do that, but I will show you that again. What we can also do is look at the siblings of tags that are within the same level of the tree. So all of these table rows here, they're all siblings of each other because they're at the same level, they have the same parent. And so from any one of these table rows, I can go to the next sibling or the previous sibling. So I don't just have to traverse by searching for specific tags. From one tag, I can jump down to the next one. And these tags don't need to be named the same thing. It just allows you to go to the next sibling or the previous sibling or all of the next siblings or all of the previous siblings. So let's have a look at how that works. So I have my T-body, and I'm actually going to start by just saying TRs is equal to tbody.contents. Now what this does is give me a list of all of the tags that are inside of my table body. So it should give me all of my table rows. So if I print TRs like this, we should see we get a list. And if I go to the top here, notice we have a table row. So now that I have the table row, I'll just show you how the siblings work. So if we go to TRs here, let's grab the very first table row that we have, and let's look at this next sibling like that. So if I go trs.next sibling, it should work, should give me something. It gives me the next table row that is after the first table row. And to prove this to you, let's try to look here. Notice this says F. The very first piece of data that we have in our table is Bitcoin, and so that is indeed working. It's giving us the next sibling. Now, in the same way, if I go to table rows 1, I can use dot previous sibling. So this will bring me back up in the tree to the previous sibling. So let's look for Bitcoin here somewhere. I'm sure. Can I search it? No, that's not going to work in my console. Okay, let's just run this again so that I get the output. I think Bitcoin is somewhere here. Yeah, there you go. Okay, BTC. So it is indeed giving me the correct sibling that we are looking for. Now, in the same way that you can look at the next sibling, you can look at the next siblings. So if I go next siblings like this from table row 0, then this will give me a generator object. Now, a generator object is just something you can iterate through. So if I wanted to look through this, I could say, actually, can I turn this to a list? I think I can turn this to a list. Let's convert this to a list, and I am able to look at all of the table rows that come after the first table row. Okay, that's the basics of traversing on the same level. So we will continue in 1 second, but I need to quickly thank the sponsor of this video and this series, which is Algo Expert. Algo Expert is the best platform to use when preparing for your software engineering coding interviews. They have mock interviews, a data structures crash course, and many other very helpful features to ace your software engineering coding interviews. Check them out from the link in the description and use the code TechWithTim for a discount on the platform. Now, I showed you previously, we can also use something like .parent. If I use .parent, this will give me the tag above me. So let's not turn this into a list. Let's go table row 0, .parent. And then notice it should give me the entire T-body tag. And just to show you, we can actually look at the name here, and this gives us the name of the tag. Perfect. Now, again, we can also look at the Descendants. Now, the Descendants gives us everything that comes after or inside of this tag. So if I go tr0.descendant and I run this, again, we get a generator object. Okay, let's convert this to a list. And let's run. And now notice we should get all of the table data that we're looking for. So multiple ways to do this. Rather than Descendants, you can also do .contents. Both of them work. And you can also do .children. Now, they work a little bit different. The children will just give you the tags that are inside of the table rows tag, whereas Descendants, I believe, is going to give you everything, even the tags that are inside of the other tags. That might be incorrect, but regardless, there's Descendants, children, and then what else do we have? .contents. Okay. Anyways, now that I've showed you kind of traversing the different levels, looking at the parent, looking at the Descendants, the contents, we want to actually complete our example. We want to look for all of the names of the cryptocurrencies and then the prices. So we have all of our table rows. So what I need to do is loop through all of my table rows. First, though, I'm just going to say prices is equal to an empty dictionary. And I'm going to say for tr in trs and look through all of them. Now, for each table row, I want to look through all of the table data that's inside of that table row. So I'm going to say for td in tr dot contents, and that should give me all of the TD tags that I can then loop through. Then what I want to do inside of here is print TD and just have a look at this. And I'll print a blank line after this as well, just so we can see what this looks like. Okay, so let's go to the very top here and notice we get TD. Okay, this looks like an icon or something. Then we get the rank. Then we get what looks like the name of the cryptocurrency. And then we get the price. So we're getting rank. Sorry, not rank. We're getting something. Rank, name, price. So we just want the first 4 here. So I don't know if I can actually index this, but let's go :1:4 like that. And that should give us, actually, I want 2:4. That should give us just the name and just the price. So let's try this now and see if that crashes. No, okay, so that's good. So now we're just getting the name and we're just getting the price. So for all of my table rows or all my table data, I'm just looking at the second and third piece of information because that's the only ones that I want. Okay, so now that I have the second and the fourth piece of information, what I'm actually going to do is change this, and I'm going to say that my name and my price is equal to this, such that I get one variable storing what the name is and one storing what the price is, and then we'll loop through the name and the price accordingly. So now let's just print the name and make sure this is working properly. Okay, so if we print name, there we go. All is good. Now we need to actually find what the name is inside of all of this gibberish. So we have all of these kind of things here, but what I'm looking for is just not the ticker symbol. I actually want the proper name, which should be Bitcoin, not BTC. Okay, so Bitcoin is right here, and this is inside of a class that has this. So let's look for this class here. Actually, maybe we can just look for the P tag. In fact, yes, let's just look for the P tag and then see what we get inside of the P tag. So I'm going to say print name.p. And now that I do this, okay, so it works up here, but here is not getting the correct name. So we'll have to fix that, but this is at least giving me the top coins. So we could just look for the top coins. In fact, that'll probably be easier for now. So let's just do that right now. So I'm just going to look for the top coins, and that will give me Bitcoin like that. Okay, so now that I have the P tag, if I want just the name, this is going to be .string to give me what's inside of the P tag. So let's run this. And now notice we are getting the correct names, although we had an error because I guess once we get down to this point, the names are no longer stored inside of the p tag. So how many names do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's just look at the first 10 table rows then, so that hopefully we no longer get this error. And there we go. Now we're all good. We're going to get the top 10 coins. Okay, so now that we have the name, we can say that the, I guess, for fixed name is equal to this. And now we need to look for the price. So let's try to look for the price. So let's print out the price and let's see what we are getting. Okay, so the price seems to be inside of the A tag. Yes, inside of the A tag. So let's just look for the A tag in each of these. Let's go price.a. Now we're getting just the link. And now what we want to do is get the actual price. So now we can say dot string. And then there you go. That gives us the price. Perfect. So now that we have that, let's say fixed underscore price is equal to that. And let's go prices at fixed underscore name is equal to fixed underscore price. And then we will print out our prices. Okay, so let's have a look here and notice we get all of the prices that we are looking for. So there you go. That is how you can find the prices from CoinMarketCap. Now, really, the point of this video was just to show you how to navigate this tree, show you the next sibling, previous sibling, parent, etc. I don't have a great use for them because you can see this is somewhat easier, right? To just look at the contents, look at specific contents that we want, grab the name, grab the price, store it in a dictionary, print it out. So there you go. Just there's an example of how you can actually use this in a real world scenario to find the price of cryptocurrency. Now, yeah, we did have an issue. That's why we only have to look for 10 here. If I wanted to make this video longer, I would make it work for the rest of them. But if you wanted to make it work for the rest of them, then what you would need to do is find kind of what happens after 10. So maybe the first 10 you find like this, and then the rest of them you find in a different way. Or you just come up with a better strategy that doesn't involve looking for just the P tag, and maybe you look for a specific amount of text, or you look for a $sign or something along those lines. Anyways, with that said, I think I'm going to end the video here. In the next video, I am going to show you how we can search across multiple websites for graphics cards prices and then compare them and return what website has the best price. I think that will be an interesting application of this. If there's anything else you guys want to see, let me know in the comments down below. Make sure to like the video, subscribe to the channel. I will see you in another one.